one good day in algebra. We are covering PO9, starting off Unit 2 with a power objective, writing and solving equations in real context. This is kind of our review of two-step equations and what things like variables and constants and coefficients are. In the pretest that you took on Tuesday, you showed a pretty solid understanding of this already, which is really good. But just kind of reviewing it for those that need it, throwing some word problems at you, and just making sure we're all on the same page here. So tell me how, we'll just jump right in here. Tell me how you would go about solving the equation negative 8n plus 11 equals negative 21. Daniel, what would you do first? Railroad tracks. And what's the purpose of the railroad tracks? Okay, so kind of it's a middle of the equation, not in the sense of its position, but in the sense that it balances things, right? That equal sign is kind of your, if you were to have like a balance scale in science, you know, that center post is your equal sign. So that whatever's on one side, negative 8n plus 11, is balanced with whatever's on the other side, negative 21. Okay, and that equal sign kind of shows you that. It's not in the middle of the equation position-wise, but it's the middle in that's the balance point. Okay, Daniel, carry on. And why would you subtract 11 from both sides? So we call that opposite operations, right? We want to undo the equation to get the variable by itself. So whatever we're doing to n, we want to undo that. And the opposite of adding 11 is subtracting 11, okay? And what happens when you have positive 11 and you subtract 11 from it? What do you get?
32. Negative 32.
Right answer, wrong question. What happens when you have positive 11 and you subtract 11 from it? Okay, Elise, they cancel out. You get 0, right? We're still over here right now. Yeah, and so they cancel out, you get 0, so that all you're left with on the left side of your equation, or your railroad tracks there, is that negative 8n. And then on the right side, as Thumper said, negative 21 minus 11 equals negative 32. Why do we have to subtract 11 from the right side as well? Elise?
That's what you do on one side of the railroad track, and you do on the other side.
And why is that? You're absolutely right. Why is that? Daniel? They're equal. You have to keep that balance scale balanced, right? If you only take 11 away from one side and not the other, now your scale, which was nice and balanced, is one side's heavier. Okay, it's going to go out of whack. So we have to make sure that we do to both sides. Next question. Why subtract 11 first? Why start there? Why not start with a negative 8? Does it matter? Gabby?
You subtract the number without the variable first.
Called the constant. Okay, and why do we start there? Why do we start there? So it does matter. You start with the constant, but why? Thumper?
Because you have to you want to find the variable, so you have to keep the variable by itself.
Yeah, and it goes back to undoing the equation, right? If we knew what n was and we were evaluating this, we would multiply first and then add, you know. But if we're undoing it, we actually work through PERMDAS backwards. Okay? We undo any addition or subtraction. It's the last thing you would do if you were evaluating the equation. So to solve it, it's the first thing you do. Who's changed a tire before? Right? Change a tire to change a tire on a car, you unscrew the bolts, you take the tire off, and then what do? You put the new tire on and screw the bolts back in, right? You reassemble in the opposite order that you disassembled. Same kind of thing here. Okay? The opposite order of PERMDAS. Okay, now we're here. Negative 8n equals negative 32. What's our second step? First, we subtracted 11 a long time ago. Then I started talking, and now we're at second step. Yeah, Swicky.
When you want to get the constant by itself, you want to subtract 8 or negative 8.
Well, we're not going to subtract negative 8 here. Divide, right. Since we are multiplying n by -8, the opposite of that is dividing by -8. And we get 4, positive 4 on the right side. On the left side, we get n. But -8 divided by -8 doesn't equal 0. So how do they cancel out here? How does dividing by -8 cancel those out if we don't get 0? Bridget.
They magically cancel out.
Magically, yes.
No,
But no, go ahead.
no,
They magically cancel out, but mathematically, what's really going on here? Brady Soar.
So you're dividing it, and then the opposite of dividing is multiplication.
Yeah. So the operations undo each other, but when we take -8 divided by -8, we don't get 0. What do we get?
You get n.
1n, right? 1n, which is what we want. We don't want to know that -8n's equals -32. That's not our end goal here. Our end goal is to figure out what 1n equals. And so dividing by -8 gets us that 1n, and n is 4. Okay. Of course, checking this, we'd plug that value back into the original equation. -8 times 4 is -32, plus 11 equals -21. It checks out. Life is good. That's it. We've solved for the variable. Huzzah. Wait, is there more? What else am I supposed to do here, Lauren?
Do we have to show our work on checking, or we just have to
We did last year.
Show your work on the checking?
Yeah, like on the test.
Like we had to
Yeah.
check it.
On the homework, yes. On the test, no. So on the homework, I would like to see you checking the answer, which I don't know what checking she had you do, but this is
We had to like, we had to do like -8 times 4 and make like a line under it and then solve it and then do plus 11.
well, I'm saving you one step then. You don't have to
So we start at
explicitly say that -8 times 4 is -32. Okay. The next one, I will not spend as much time talking about the next one, but same idea here. I mean, they're called two-step equations because there are 2 steps required to solve them. Identify the operations that are in the equation. I see I'm multiplying 3 by n, and I'm adding 17. So let's just undo that. What's our first step? Bridget? Subtract 17 from both sides. That's right. Okay, subtract 17 from both sides, which 17 minus 17 equals 0. So that cancels out. And on the right, to keep this equation balanced, 77 minus 17 is 60. Then, step 2. Soybe. Divide by 3, and n equals 20. Okay? Prove it to me. Okay. Well, 3 times 20 is 60, plus 17 equals 77. Okay. The next one, Bridget, yes?
So, the checking stuff, is it just on like that one side, like the 60 and the divided by 3 and the 20 and the 37? You know how like there's 2 sides?
2 sides of the equation?
No, of the railroad track.
Oh yeah.
Like, and it's just the one.
Sorry, mine are curvy. Yeah, go ahead. What's your question?
You know how there's 2 sides?
Yeah.
We're only doing one of them for the checking, right?
Yes.
You just plug in the.
No, I know.
However you want to check it, Bridget, I think is okay. As long as you can say, like if I ask you to defend that n is indeed 20, you can show me and say, well, this is the reason why. There are probably several ways that you could show it, and whatever you want to do is fine. The next one, n divided by 5 minus 6.5 equals negative 4.5. First step. Who would like, Erica? I would add 6.5 as well. Okay, the opposite of subtracting 6.5, the opposite of a negative 6.5 is positive 6.5. They cancel out, and n divided by 5 equals positive 2. If you wrote negative 11, you went the wrong direction here. Okay, negative 4.5 plus 6.5, you're going to the right. From negative 4.5, you end at positive 2. So n over 5 equals 2. Second step, Erica, bring us home. Multiply both sides by 5. Yeah, in this case, since we're dividing n by 5, the opposite of that is multiplying n by 5. They cancel out, and n equals 10. Okay? And of course, your check afterward. Last one. Go ahead and try it on your own. I have to sneeze, so I'm going to pause the video, and we'll talk about it then. N divided by negative 6 minus 4 equals negative 15. Anyone new to the conversation like to jump in? What would our first step be here? Quinn?
You do the normal fraction and you add 4 to the
Yes, add 4 to both sides. Get it out of there. Negative 4 plus 4 equals 0. So n divided by negative 6 equals negative 11. Erica? Second step, we're going to multiply by negative 6. And n equals positive 66. Negative 11 times negative 6, positive 66. (66) divided by negative 6, checking this now, equals negative 11. And negative 11 minus 4 equals negative 15. Okay. The goal is for that two-step equation to be your comfort zone, right? Because as we get further into algebra, you're going to see lots of different types of equations. When we get to PO10, we'll have combining like terms, we'll have distributive property, we'll have variables on both sides. But that two-step equation, right? If we can get there, then I want you to be like, okay, I got this the rest of the way, right? Opposite operations. One thing on the pretest that did not go so well was the defining or identifying a coefficient versus a constant. Okay, so the 3 parts of your standard two-step equation, it'll have a variable, you'll have your coefficient, and you'll have your constant. The variable, of course, is the unknown value. And it is usually a letter. It can be a symbol also, but usually it's X or N or Y or Z or something like that. Okay, and it's what can change, right? It's what's being tested. Just like in science, when you do an experiment, the variable is something that you can't necessarily control, or it's what's being tested. It's what you are doing to kind of rationalize the experiment. Okay. A coefficient. Who does know what a coefficient is or what its function is? Elise?
It's like how many of the variables?
It's how many of the variable that you have. It's the number before the variable. Okay? Number before the variable. Who said uh-oh? Oh, everything okay? And you woke up saying uh-oh? Okay. Good thing we record, I guess. You can go back later. Number before the variable. And it's what you are multiplying the variable by. So it's the operation between a coefficient and a variable you are multiplying. Okay, Elise said it's how many of the variable that you have. That's kind of one definition of it. How about a constant in an equation? A constant. Julia? Right, it's the number, it's the lone number, okay? It's what doesn't change. It's the number that is sitting by itself, just like Mr. Schultz on a weekend in high school. Okay. And the reason why it's called a constant is because its value isn't dependent on the variable. Its value doesn't change. And we'll talk about what that looks like in the word problem here. What word can't you read, Lauren? Variable. It's a combination between poor penmanship and a poorly calibrated board. I did calibrate it yesterday. You saw me and it was still off. You can only calibrate something so many times. I mean, look how. Well, it throws off my rhythm when I'm writing a word. Okay, so let's take a look at a situation where you need to write the equation yourself and therefore need to identify what the variable, coefficient, and constant are. So you sign up to help a charity with preserving the rainforest. How kind of you. They ask for $20 up front, and then you'll give $2 per month after that. Write the equation. How much money will you have given after 6 months, 8 months, 2 years? Maybe. Give me the equation first, then we'll work from there. Quinn?
2 times the amount of months plus 20.
Okay, so 2m plus 20. Our variable in this equation is the m. Why? Because that's what's changing. That's what we're testing. We want to know how much money will we be giving after 6 months. Then we change it to 8 months. Then we change it to 2 years, right? It's what part of the equation is being tested or changing, okay? Our 2 is our coefficient, right? Because that's kind of the rate. It's $2 per month, okay? It's how much money per month. Its value is directly affected by the variable. The more months that we're contributing money, the more money we're contributing, okay? 20 is our constant because that value stays the same. You sign up, you give $20. It doesn't matter how long you continue to be a part of it. You still gave that $20. That part doesn't change. Okay? So after 6 months, 2 times 6 plus 20. Shout out the answer. Sorry. If it sounded like I said mumble the answer. That wasn't. Okay. Next one. 2 times 8 months plus the initial 20. Again, notice what changed here. The variable changed. Now it's 8. Our coefficient, this value, that product, will change because we're a part of this longer. For that 20, just by itself. Always constant. What do we get? How much money after 8 months? 36. What are we plugging in for our variable for 2 years here? Why 24?
Because there's 12 months in the end.
Right. If our variable represents the number of months, then our what we're plugging in for it has to be in months. Okay? So 2 years equals 24 months. After 2 years, you've given $68. Okay? Questions on any of that? All right. The next one. Mr. Schultz has 3,039,001 hairs on his head, and each day he loses 60 of them. Write the equation. How many hairs will he have left after 120 days, 1,580 days, or 50,650 days? What's the equation, first of all? Yeah.
3,039,001 minus 60n.
Okay. Our variable n, right? And you could probably, well, I'll replace it with d for days. Okay. But our variable, we want to know, what are we testing? How many days? How does that affect the hairs I have on my head, right? Our coefficients, negative 60. That's the rate at which I'm losing hair, negative 60 per day. And then the constant, what do I start with? 3,039,001 hairs. So what did you come up with after 120 days? 3,039,001 minus 60 times 120. We're just replacing that variable, the number of days, to be 120. Yeah? 3,031,801. That's still a lot. I can work with that. That's not too bad. How about after 1,550 days? Nothing in the equation changes except that variable, which will affect that negative 60, because now I'm losing more hairs, right? More time has passed, but that starting number is still constant. That's what I started with. How many hairs after 1,580 days? Elise?
294. Oh, wait, no. 2,944,000.
What was the last part? 201. Okay. And then how about 50,650 days? Start with 3,039,001. I lose 60 of them per day for a lot of days. 50,650. How many hairs do I have remaining, Quinn?
One.
Just one. I sure hope it's long, though, so I can like curl it around, wrap it around, comb over back and forth and back and forth and back and forth. Oh, maybe. But really, though, 50,000 days is like 138, 140 years old. I think if I could live that long, be left with one solitary hair, that's an even trade-off. But
Then you beat Charlie Brown. What about the 50,650 first day?
well, then I'll have to put sunscreen on my head. Any questions on that? Okay. The back side, or the second page, rather, is what you're going to do for homework. You've got 8 of them to practice just standard two-step equations. Just like the first 4, you've got some with multiplication, division, then addition, subtraction, but all 2 steps to solve. So make your railroad tracks, write the steps, show you checked your answer, nothing too fancy there. Then 2 word problems down at the bottom. You are just starting to collect baseball cards and already have 30 that you got from your parents. You go to a trading store with 3 of your friends with the agreement that however many cards the group gets, you will divide them evenly among the 4 of you. How many cards will be in your collection if the group gets 40, 96, 224 cards? So you're writing the equation and then solving it for the variable for those 3 different values, just like on the first page. Then a question about scuba diving. Intriguing. When this video link gets posted on Google Classroom, like I said, there will also be a Google question form where if there's anything that you don't want to ask now, don't get time to ask, or comes up while you're doing it, okay, like, hey, what about this situation? Ask it there, and then when we come back on Monday, because tomorrow is the retake day, so you have until Monday to get this homework finished. When we come back on Monday, I will address it and make sure that I cover it in the lesson. Soybean. This homework is due on Monday because tomorrow is a retake/con day. I will not be checking this in. Any other questions, comments, concerns, complaints, compliments, congratulations, or criticisms? Soybean. Thank you for what?
Yeah.
Aw, thanks, Soybean.
No, congratulations. that you came here on time today.
Oh, in the morning, you mean?
Yeah.
Yeah. My arrival time, just, it all depends on, oof, children. Oof. Anything else? All right. That is how you math.